point of view, you should get to the exact same place. Questions to hear?
So velocity is the slope of the change in displacement over the change in time graph? Is that the right way to express that?
The wording's a little bit off, but
That's okay.
yeah, the
What would be the right wording?
velocity is the slope of either the position versus time graph, or the velocity is the slope of the displacement versus time graph. You said change in displacement.
Yeah, no, I know the wording is important. So you say velocity is the slope of the displacement over time graph.
Versus time graph.
Versus time graph.
Although, given the meaning of the word over, that would actually work too. It's the displacement over time as time progresses. All right. I was about to tackle the problem that Caleb had posed earlier. So let's do I need to get rid of all this. All right, so A time ball is at rest in hand. B is at rest in hand, and hand starts to move upward. B, time the force from hand equals weight of ball. C, time ball leaves hand. We actually don't need that. We don't need that one. C, time ball is at peak. D, the time the ball is at same position as at time E. Time. I'm gonna have him catch it instead of it hitting the ground. Time. Weight of ball. Equals force from hand. This should be magnitude of force. Magnitude of weight. Magnitude of force. F, time ball stops, and stops. With there, okay. That'll get into a subtlety. All right, so we're gonna do position, displacement, velocity, acceleration. A to B, B to C, C to D, D to E to F. For some variety. Positive position equal to 0, position negative displacement, positive displacement, 0 displacement, negative velocity, acceleration. All right, and judging from past students, this is greater than, and this means less than. So I'm going to draw a little picture here. That's a person. That's A, B, C, D. So he's catching it. So E and F. I do need. No, I need to do something else here. Let's see. You should just let it hit the ground. Just make E position at time E equals position at A. All right, so he starts with the ball down here, throws it up into the air. So at time A, it's at rest in the hand. As he throws it up, he exerts a force upwards. There's still weight acting on it. I have weight acting down, normal force acting up. There is a point in which the normal force and weight will be equal in magnitude, and then it's touching the hand just a little bit longer, but it starts on its journey upwards. When it hits the peak, it's going to come back down. It's going to hit that point of, it leaves the hand, and then wherever the hand was at point A, the hand touches it again, or touches it slightly before that, but we get the weight of the ball is equal to the magnitude of the force from the hand, and then stops a little bit lower than its initial release point. So throwing it up and then catching it, not like that. Okay.
So the writing you added under E, the position at time E equals position of A, is that just like the same, or a different way of expressing the same thing? Or did we add something else? I'm just confused.
No, as it's coming down, so when he throws it up, he starts from here, he basically releases it here. When it's coming back down, he is not catching it at the same spot in which he released it. He's catching it a little bit lower. And
Okay.
then it stops down there.
Okay.
We need to establish two conventions just so we all have the same answers. I'm going to say up is positive. And I am going to establish 0 to be at, let's see, that's the starting point. We'll make 0 here. Now, when actually solving physics problems, it's often convenient to let the zero be the starting point, but for the sake of this, I don't do that.
So, just before we keep going, the list of values with the less than and the greater than, is that something that you would give to us, or is that just like another way to express?
Another way to express it, there's 4 ways I give you to express it. One of them was the grid we did before there, and then the plus minus.
Yep.
This is a third way of doing it.
Okay.
I think it's the second one on the list, or first or second
okay.
one, actually on the list. And then the other way is I break this up and you shade in the positive, 0, or negative, as opposed to writing the actual plus, minus, or 0.
Okay.
And you can do that. Just to get them all.
And
So
so,
now we've covered all 4 ways.
so B and D are they on the 0 line, or are they slightly below it?
B and D are on the 0 line.
Okay.
All right, so personally, I think position is the simplest, but let's start with the simple one. Acceleration is not the simplest one. All right, where is position 0?
B and D?
Yep. So it is 0 at B and D. So over here, position at B, and I'm just shading the 0 part. 0. All right. When is it positive?
C.
At
C.
At C? What about between B and C and between C and D? Yes. Again, it's not going to go from positive to 0 or positive to negative or negative to positive without going through 0. So if I establish where 0 is properly, if I can get one point in between that's positive or negative, it should be the same for everything in between. So it's positive between B and D. Now, if you're going to do the bracket parenthesis method, please make sure I can tell the difference between a bracket and a parenthesis. It is not always simple when I get something like that, or all right, when is it negative? Okay, so at A, it is negative. So what about between A and B? It better be, because it didn't cross through 0 there. And then what about up over here?
Negative between D and E? And then negative at E as well? And then negative between E and F? Am I saying that right?
Yeah, between E and F.
Okay. And then negative at F as well?
Yep. All right, so we would write that at square bracket A to B, and then D to F. And if you graphed it, I don't ask 110 students to graph it, but if you graphed it, this gives sort of a sense of what it looks like. It goes up and then back down. All right, displacement. Where is the displacement 0?
B and D.
Nope. What is displacement again?
It's the distance traveled with respect to the starting point?
And E.
Where is with respect to the starting point?
A and E?
Yeah, A is the starting point. The problem starts at A, so that's the starting point. So displacement is 0 at A. And I'm going to and you said E. All right. So over here, it's 0 at A. Where's the positive?
All between A and E.
All right. Use the marker on there again. All right, so. And where is it negative?
Between E and F,
And what about at F?
it's negative as well.
Okay, so that's negative. So not including E, but is including F. There we go. All right, velocity. Still find it helpful to pick out when it's at 0. When is the velocity 0? At C, velocity 0. Okay? Anywhere else?
F?
Okay. And one more place.
A?
Yeah. That was the ball is at rest. So at rest means not moving. All right, so I have my zeros now, so I know in between, that's either gonna be plus or minus, that's plus or minus. Please recognize that just because I hit a 0 doesn't mean I'm gonna immediately flip to the other side. It is possible to go from positive 0 back to positive. It's just that if I go from positive to the negative, I have to go through 0. All right, so what about between A and C? Positive or negative?
Positive?
Because it is indeed going in the positive direction. And what about between C and F?
Negative?
Because that's when it's falling. So in this notation over here, the velocity is positive. We said between A and C. Oh, so this is A and C and E. This is between A and C. This is, oops, there should be an F there. And between C and F.
Those are both parentheses, right?
Yes. And now acceleration. This is the tough one. So let's hit the obvious ones, or the easier ones. When is it speeding up? When it's falling, okay. So it's falling between C and F. It's not speeding up actually the entire time because it does eventually stop. So at what point does it stop speeding up? Well, at F, it is stopped, but
So E?
at E. Yeah, that's what this is saying. This is when, because I got two forces acting on it. While it's in the hand, two forces. I got normal force acting up and weight acting down. Now it starts out with normal force being bigger than the weight. That's why it's suddenly accelerating upwards. But at some point, it's not touching the hand, the normal force is 0. So there is a point between there where it goes from the normal force is bigger than the weight to the normal force equal to the weight to the normal force is less than the weight. So this is the point in which it stops speeding up. So while it is speeding up, acceleration and velocity are the same sign, so it is speeding up from C through E, so acceleration is negative. Between C and E, acceleration and velocity, same sign. There's another region where it speeds up.
Is it between A and B?
A and B,
Mhm.
yes. So between A and B, velocity is positive, it's speeding up, acceleration is positive.
So it's correct to say that the ball's acceleration is speeding up between A and B and slowing down between B and C?
That's vague language, because you said the
Okay.
acceleration is speeding up, that,
How would you express it?
I could just say the ball is speeding up.
Okay, so you'd say that the ball is speeding up between A and B, and it's slowing down between B and C, and then it speeds up between C and D, and it slows down between D and E?
E and F.
E and F, okay.
Yeah.
Okay.
So in those regions where it's slowing down, it's gonna be the opposite sign, so if between B and C, it's slowing down. And so acceleration is the opposite of velocity. Between E and F, it is slowing down, so my velocity is negative, so my acceleration is positive. And so now we're sort of left with the other points. If I'm going from negative to positive, I have to go through zero.
Yeah.
So that's gotta be a zero there at E. And I gotta have a zero here. So now we've just got 3 blocks left. At C, what's happening? At A, what's happening? And at F, what's happening?
Is acceleration 0 at F? And that might have been the mistake that you were talking about.
It is not 0 at F. And this is a real subtlety here. If these are the only mistakes that you make, more power to you.
C is negative, right? Because it's still slowing down.
Which one? At F?
C?
At C? No, at C it's negative?
Yeah.
I wouldn't say because it's still slowing down, it's that transition, it's turning around.
Yeah.
But what, at C, tell me all the forces acting on the ball at C.
Gravity is pushing it. Or weight is pushing it down.
Thank you, yes.